What's up? So in the last video we were talking about how do we connect JavaScript to a simple smart contract, right? And the smart contract that we had deployed was a counter contract where you stored one value, and through smart contract, basically through transactions and everything, you increase that value, and we added methods to read the value and all that. So today we are going to work on creating our own token. So what are tokens? Tokens is like creating your own currency that lives on the blockchain. A lot of new tokens that you hear of cryptocurrencies are tokens on the Ethereum chain. So Shiba Inu is a token on Ethereum chain. Tether is a token on the Ethereum chain. Chainlink, 0x, all these are tokens on the Ethereum chain. So today what we are going to do is we are going to create our own token called my token, and we are going to deploy that token to the Polygon chain because free gas, not free but like low gas. And hopefully by the end you will be able to understand how to create your own token and understand the working behind a token. Before we begin, please make sure you hit that like button, subscribe, comment, the drill. It keeps me motivated, helps me with new people, figuring out the channel. And it's generally nice for me. Let's get started. So the first thing that you need to understand is this EIP-20, which is an Ethereum Improvement Proposal number 20, which was the token standard written by Vitalik Buterin and Fabian. I don't know how to pronounce the surname. It's also called an ERC-20 token standard because the category is ERC. The standard basically lists down what each ERC-20 token should do so that every dApp can adhere to that standard, to this standard, and then work in tandem without any problems. This thing is also sort of summarized on Ethereum's website where the ERC-20 token standard is introduced. There are basically 9 methods that your smart contract has to work with, respond to, which are name, symbol, decimals, total supply balance of, transfer from, approve, allowance. Okay, these are the 9 methods that are there that if your smart contract adheres to, it's sort of considered an ERC-20 token. On top of these 9 methods, there are 2 events as well that your smart contract needs to emit. So let's go to Remix and start writing our own smart contract. So I am here at Remix. I've opened a new workspace, I believe. What I'll do is I'll go and create a new file over here, and I'll call it my token.sol. The first thing I'll do is pragma 0.8.4 or 0 probably. Next we are going to define our contract with name my token, and that's how you create a contract. Now let's go back and see what are the methods. The first 3 methods are name, symbol, and decimals. Now I'll explain what they do. Name is very self-explanatory. What is the name of this token? So what we're going to do is string public name is equal to my token, right? And now because it's public variable, so we get a name method by default, so we don't need to do anything else. Another thing that we can define over here is the symbol, and I will be MYT, that is the symbol. So now we have basically the 2 methods covered. Now the third method is called decimals, and it sort of returns a uint8. Now what is a decimals? What do we mean by decimals, right? So basically if you go to EIP, they tell you it returns the number of decimals the token uses, like 8 for example. So if you get 1 and then 10 zeros worth of our token, it means you've received 100 tokens, because whatever number you receive, you have to sort of divide by 10 to the power decimals. This is done because there are no fractions, there's no float or anything like that on Solidity. So what we do is basically pass around integers. Even Ether, when you send or receive, or Matic for that matter, you send it in WEI. That is basically one, like the smallest unit of Ethereum, and then you send that amount, and then the UI basically divides it by correct numbers and shows you what is the right value, or the right amount that you've received. So let's say in our case, we will also go with 18, because that is what Matic or Ethereum as well does. So let's say we go with 18, and that's it. We are done with the first three methods. Okay. Now the fourth method that we see over here is total supply. This will define how many tokens would be there in circulation. Now this can be a constant number, or you can keep changing it based on X or Y or Z or whatever. But for explanation today, we're just going to keep it a constant number, which this method is supposed to return a uint 256. Oh my bad, this was supposed to return uint 8. I did a string over here, which is of course not good. The other thing that we have over here is total supply. So I'll copy this. Again, total supply for our case doesn't need to change, so we will just make it public. What we will do is we will have let's say 100,000, 10,000, 100,000. I just want 100,000 tokens. All right, so what I'm going to do is oh, this should be 256. Yeah, I'm going to multiply this by 10 to the power decimals. Okay, let's just try and compile our contract here just to get some sort of confidence that we are in the right direction. So I'll compile this one, and there's a problem. Oh, the problem is I forgot to write Solidity. And while I'm at it, I can add an NSPDX license identifier. Oh, looks like it worked. So now we can see, let's just deploy this to somewhere and see what happens. So yeah, we have four methods now. Decimals, which returns 18, name, my token, symbol MYT, and total supply 10 to the power 23, I guess. Great. So we have already covered 4 out of 9 methods. Nice. Now the fifth method is balance off. So let me just copy this and paste it over here. And let me just add braces. Okay, so what does this method do? If we go back to the standard, which says returns the account balance of another account with the address owner. So whatever owner we send over here, this is supposed to return the amount that owner has. All right. So to do that, what we should do is create a mapping. Now, what is a mapping? Mapping is sort of like a hash in other languages. So you input key and you get a value. All right, so that's a mapping. Now how do we create a mapping in Solidity? We write mapping, and then we do address, which is the type, basically the key type, and the value type, which will be uint 256. Actually, I can make this public as well, right? So I can just be like public and balance off, and done. Boom. I believe this should be decent. Let me just compile and check. Compiled, deploy. Oh yeah, it works. Let's say I copy my account. I this over here, it says 0. Great, because right now there's only supply but nobody owns it. Awesome. Oh my god. So balance off is also done. Okay. Now the next method is transfer. But before that, one thing that we've missed over here is we have created supply and everything, but nobody owns any tokens. So what we're going to do is we're going to create a constructor for my token. It doesn't need any arguments, and what we're going to do is we will add balance of msg.sender is equal to total supply. Now what have I done here? I use this balance of mapping or hash, if you will, and I used a key called msg.sender, which basically means who is the person, who is the account who is trying to run this method or create a transaction which runs this method. So our account from here is the one which is doing that. So what we're going to do is we're going to transfer all the balance to this msg.sender, which is this account, and we are basically giving the value total supply so that only this account can spend these tokens. Now let me just compile and deploy again. Oh, there's a problem. Right. I forgot it's a constructor. I'm still in my Java brain for some reason. All right, it compiled, and I go here. I delete whatever contracts have been deployed. I deploy again. This time, if I check, if I copy the value of my address and paste it over here and figure out the value, it says 1 and a lot of zeros in supply. So you can see the values are same, right? It's because I own the whole the whole of this token. Amazing. Now what do I do with just owning the token, right? I should be able to transfer it to somebody else. So there is a transfer method available for us to do exactly that. So I'm just going to copy that and I'm going to paste it over here. Now the first thing that we need to make sure before we transfer our tokens to anybody else is that we own these tokens, or at least the amount of tokens that we are trying to transfer. All right, so what we're going to do is put a require statement. Now require, what basically it does is it makes sure that the condition is fulfilled, is true, otherwise it throws an error. Okay, so we need to make sure balance of the msg.sender, the person who's trying to call this method, their balance should be greater than equal to the value that they are trying to transfer. Okay, and we can add a method, add a message over here. This basically makes sure that we have enough balance. After that, what we're going to do is we're going to be balance of _2 plus equals value, and balance of msg.sender minus equals value. Actually it should be reversed. So first we deduct the value from the sender and then we send it to the receiver, add it to the receiver's ledger, and then we return true because that's what we're supposed to return. And voila, like just like that I can transfer any token to anybody else. So let me just compile it again. Okay, there's a problem. Of course, I forgot the underscore. Compile. Yep, it compiled. I'll just remove the old contract and deploy again. Whoa, there's a transfer function, as you can see. If I check my balance right now, it has some decent balance. All right, now what I'm going to do is I'm going to transfer this transfer some amount to, let's say, C5, and the value that I'm going to transfer is 1 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 one token basically, because we have 18 decimals. So this is how I transfer one token to somebody else. Actually, I'll copy the second one. Okay, and now I'm gonna paste it over here and click transact. And as soon as I click it, a tick mark comes over here and it says blah blah blah. Okay, now if I check the balance of my C4 address, the first address, you can see that it has reduced. All right, and if I check the balance of the address that I've just copied, you can see that it has increased. Great, great, great. That is how you transfer your tokens from one wallet to another. Okay, this, by the way, this is just for ERC-20 token. This is not how you transfer Ether or Matic for that matter, but this is for the tokens that are built on top of these chains, the ones that I've listed earlier, like DAI and all, or USDT, blah blah blah. Great. Now, one thing that I've seen that if you are going through this, if you have gone through this, you will realize is transfers of zero value must be treated as normal transfers, which we are doing, and they should fire the transfer event. I mean, it's not for it's for non-zero values as well, like transfer value amount of tokens, and must fire the transfer event, right? So the function should throw if the messages caller's account balance does not have enough tokens to spend. That we have already done. We have not fired the transfer event. Now if you go back over here, you'll see that the transfer event has these many things. So let me just copy this transfer event and paste it over here. Now the transfer event has three things: the from, the to, and the value. To fire this event, what we do is we go here, we write emit transfer with the capital T, and then we fill in these values. The from is message.sender, the to is _to, and the value is _value, and that's it. That's how you emit an event basically. So let me just close the delete the contract that we've put there, and I forgot to add a semicolon. Yep, works now. I'll deploy it again, and let me just transfer some value to myself. Whatever, transact. So it works. If you open that open the transaction that was done, you will see the option called logs. There you will see what the event was emitted. So the event transfer was emitted with the values from, oh sorry, arguments. The first argument is this one, which is basically from, the second argument to this, and the third argument value this. Okay, so this is how basically you emit something, emit an event, which is mostly used for logging purpose. But anyway, so this in itself is a decent token. You can send your token to somebody else, they will receive it. That's it. Like, this in itself is a great token, but it's not ERC-20 compliant yet, because we need some more methods. And why do we need those methods is something which is very interesting. So now the next methods that you will see basically is transfer from, approve, allowance. Okay, these are the three methods that we have not covered yet. And what basically these methods do is allow others to spend your token. Now why would you let someone else spend your tokens? It's so that you can automate a bunch of things. So let's say you are trying to buy an NFT, and the NFT costs 50 tokens, right? So you will go and you will tell the marketplace that, take my bid of 45. If the person is fine, just spend my money and give me the NFT. So marketplace will ask you for the permission to spend that amount. Once they receive that permission, they will save that bid, If the user is fine with that bid, they accept. The marketplace's smart contract takes your token, sends it to the person, and takes their NFT and gives it to you. So this is why the approve, allowance, transfer from these methods, they will be very helpful. Now, how do we, get to do that? We'll just go ahead and see now. The transfer from method sort of is used to withdraw workflow, allowing contracts to transfer tokens on your behalf. But before, going towards that, first let's see the approve function. Let me just copy this approve function. What it does is it allows a spender to withdraw from your account multiple times up to the value amount. If the function is called again, it overrides the current allowance with the value. Great. So I'll just paste it over here and open this. Now, how do we keep a track how much someone is allowed to spend other person's tokens? So to do that, we will basically have a mapping whose value is also a mapping. What do I mean by that? Let's say I create a mapping of address key which returns another mapping where the key is address and we have the amount that can be spent. Let's keep it public and call it allowances. Oh, actually the function name is allowance, so I'll just call it allowance. All right. Now what the approve function is supposed to do is initialize values over here for the message sender, with whatever amounts, with whatever arguments that they send. So how it will work is allowance message dot sender. We get another mapping. Here we write underscore spender. So this spender is allowed to spend the value that we've received, and we're supposed to return true once this is done. Another thing that you will see is that in the events there is an approval event which should be triggered on successful call to approve. Okay, so what I'm going to do is I'm going to create another event called approval, and I'm going to emit this event for message sender with the spender and the value. Awesome. So now approve function is also there. Now the only function that we haven't implemented is transfer from. So let me copy this function. So this transfer from function is basically called from an approved spender on behalf of the from and sending the value to 2. If you check it out over here, it says transfers value amount of tokens from address from to address 2. It must fire the transfer event. The transfer from method is used, as a withdraw working flow, whatever. It should make sure that you are allowed to spend that token for that from. So here you can read the function should throw unless underscore from account has deliberately authorized the sender of the message via some mechanism. If you remember to throw an error, we use this require and it sort of throws an error if the condition is not met. So we're going to do something similar over here. We're going to require the allowance from and for the message sender to be greater than equal to underscore value. Another thing that we should check over here is that the balance of from is greater than equal to underscore value. Okay. Not allowed to, not approved to spend, not enough tokens to transfer. Great. So we have added 2 conditions, and if the 2 conditions are met, we basically transfer the value from the from to the to. We will go balance of underscore from should be reduced by the value. Balance of underscore to should be increased by the value. And if you remember, in the approve function, it said allow spender to withdraw from your account multiple times up to the value amount. So we should ideally reduce the allowance with the message sender. Great. We need to return true as well, and I think we need to emit the transfer event. To emit this, it will be from to value, and that is it. This is how you create an ERC-20 token. These 48 lines of codes, this is a complete token in itself, which you can deploy to the main net or whatever net, and you can trade these for other tokens, put it in a dex, put it anywhere the tokens are available, are allowed to be put, and just run with it. So let me just go and compile and make sure it works. One thing that I realized during the edit was that I forgot to emit the transfer function in the constructor after giving all the balance to message sender. So to make sure that your token is ERC-20 compliant, just add the emitting of that transfer function in the constructor. Yeah, it works. Oh. I'll delete these and I'll deploy. I'm fairly certain there are no bugs. It's very small code. You can just fit the whole code in this view. So this is basically how you create your own token. Hopefully in the next video, what we'll do is we'll deploy this token. We'll interact with this token and create some sort of functionality for token holders, or just create a simple interface so that token holders can, send this token to other people and whatever. Hope you liked this video. Please make sure to hit the like button, subscribe, comment, all the drill, so that it keeps me motivated to create more videos. And I hope to see you next week. Bye bye.